I'll just give a quick overview of everybody, and then when you talk, you can give some more detail. Here we have Steve Van Trees, who used to be my manager when I was in Air 130, and has been a key person in UAS. And you know what? I'm not even going to get the detail about who they are. I'll let you guys handle that. Next to him is Wes Ryan from Kansas City. He's a small airplane directorate. And it is officially called the UAS Directorate too? Or no? Not yet. Okay. Right now it's just a small, okay. Right now it's a small airplane directorate. Everett Roshan from AFS 820, is that right? Flight Standards, who is key in the small aircraft, small UAS rule. And Ely Nasser from AFS 240. So is that right? Yeah. Okay. So those are our 4 panelists on stage, not human factors specialists, although Wes knows quite a bit about human factors.
I stayed at a Holiday Inn Express last night.
Yeah, exactly. And in the front row, the human factors specialists, starting on this side, we have Sherry Chappell, who works in my office as a program manager for human factors research and has been involved with a lot of UAS work. Phil Smith from The Ohio State University, I had to put the "the" in there, and is also a UAS Center of Excellence representative. We have Lisa Fern from NASA, been one of the key people in the DAA work going on and with SC228. Valerie Gauran, although I'm not sure if I get that spelling or the pronunciation. Yeah, Gauran. Valerie is from MITRE, and we have Jeff Morrison from the Office of Naval Research. I think a lot of what Mark Draper said will maybe you can touch upon that regarding autonomy and everything. Kevin Williams from the Civil Aerospace Medical Institute, CAMI, we call it CAMI, in Oklahoma City. I've been working with Kevin for a really long time as well on all sorts of UAS stuff. Steve Pliszka from the UAS Integration Office, the only one in the FAA that is got the official UAS and human factors label, and so I'm glad to have Steve here too. And Wes Olson from Lincoln Lab. Wes does a lot of work with TCAS and ACAS and also some of the DA work as well. And so that's the human factors specialists. I think there's no one else in the crowd that needs to move up, I don't think. I think that's everybody. So Steve Van Trees, why don't we start with you and just, where's the, oh, of course, Kathy. Sorry, yeah, I didn't see it. Kathy Abbott, okay, so Kathy Abbott is, I didn't see it because you weren't sitting down. You can come up here. I kind of forgot. The agreement with Kathy was that we were going to sort of moderate this together. She was on the agenda as a panelist, but before we start with Steve, I'll just, do you want to say a few words about who you are and anything that I didn't say already?
I was trying to sneak out of the room. Thank you, Sherry. No. Just kidding. I'm Kathy Abbott. I'm the FAA's Chief Scientific and Technical Advisor for Flight Deck Human Factors. And even though it says Flight Deck, that also applies to UAS. At least I would certainly think that that is the case. I thought the last panel was very, very interesting and very useful to hear the summary of that. One of the things I'm just going to put out there, since you gave me the opportunity to talk, is the FAA has something that they call a safety continuum to recognize that the same level of safety doesn't necessarily apply to every type of vehicle, every type of operation, and every type of airspace. So I guess one of the things I would hope that this panel would talk about is maybe how that gets applied in UAS. So I'll leave it with that.
Yeah, there you go.
And then,
got something for Wes to chew on at least. So okay, we'll start with Steve Van Trees, and all of you, if you want to take a few minutes and, like I said, talk about who you are and what your world is, and then we can have the discussion when you get all done with this panel.
Good. Okay. Thanks, Kathy. Thanks, Bill. Yeah, as I go through my career, one of my greatest claims is going to be the people I've hired. So Bill is up leading the symposium, and Steve George, was my first lead for UAS. In 2007, Air 130 was the only UAS office in the FAA, so it's come a long way. Since then, I've spent my entire FAA career, 19 years next week, in Air 130 aircraft cert. We do cross-far part policy and comm, nav, and surveillance. I've always been a comm guy. I came in as a data communications engineer and have worked UAS, originally part of kind of the early JPDO efforts, and then had a big part on the Sherry McGarrett's FAA UAS ConOps, and stayed with it since then. Ed Wagner gave me a nice setup coming in that, together with NASA and a tremendous number of industry people, I've been on leading role with SC228, the UAS Detect and Avoid and Command and Control Committee at RTCA the last 3 years, and it was formed after SC203. SC203 tried to do everything in the world for all airspace and all sizes of aircraft, and then the way the FAA does, our ambitions contracted a lot, and we said, okay, let's just do 2 MOPS. Let's just get a bunch of engineers and send them over there. So that's what we did. And 3 years ago, we had said we're going to have the command and control MOPS at the end of July 2016. I'm happy to report we're going to be a day early of our schedule 3 days ago, where NASA is producing the document this afternoon, and we're sending it to RTCA. So we have kept schedule, and part of it, as we talk about human factors, is that document is about 50 pages of standard and about 750 pages of how we got there. I mean, what the maths on top of the MOPS were. So I guess one of the things we learned in 228 was how much human factors there was even in the initial system allocation. You know, that we come to something and we say, okay, well, what kind of link do you need? And what we had to do was go over to Working Group 1, and we had to ask them a set of questions, you know, and really heavy human factors flavor. First, what's your detect and avoid automation architecture? You know, what are you trying to do? Is the pilot in the loop? You know, is the pilot on the loop? Is it autonomous, right? And that drives you to very different communications choices. If you need a link made of spun gold, or you can lose the link because, you know, the automation has it. You also look at what the lost link automation architecture is. You know, do you return to base? Do you have no fly areas programmed, or is it cooperative? You know, and Wes and I have talked about this for years. What's your air-ground automation, you know, distribution? You know, is it all on the ground? You know, is some on the aircraft and some on the ground? You know, Wes has said he doesn't want us hand flying the aircraft such that we lose the link. We've automatically got a flyaway that the aircraft has to continue in safe flight on loss of link. And on the other hand, you've got a Steve George that will tell you that you can't rely exclusively on automation for detect and avoid. You can't just, you know, put TCAS directly to the autopilot and you decide that's, you know, how you're going to keep flying. That certainly isn't the way we're going. So that even driving toward what the link had to be, what the performance parameters were, what we could get out of C and L band, that was really the beginning of it. And so the whole question from an aircraft cert perspective is we don't much care how well it works. We really care a lot about how badly you get hurt when it fails, you know, so that if you lose the control link, you know, we think that's probably hazardous unless you mitigate it. You know, we think if you lose the comm link, that's major to hazardous. And Wes, I'm sure you'll hear from him next, but is very much on the idea that, you've got to mitigate it down. People are going to be coming in, wanting to fly, wanting to do operations, and you can't depend on, one piece of automation in that aspect. So I think the other thing that's been clear is what 228 did exclusively. We are exclusively up and away. We are not UTM traffic. We are, Class D, E, and G, transitioning to Class A to do work. We are not mixing in that traffic, except obviously you have to. If you came up, you've got to get down. There is some interaction, but one of our greatest challenges is what does the demographics look like? What does the rest of the world look like? And Part 107 and beyond is getting a lot of the action, but we also believe that there's going to be action in large UAS, which is where 228 is going. And I think the other thing to keep an aspect, part of my day job is still data communications, and I was talking to the NTSB, and they have I'm sure you know this, they have an old recommendation on UAS, the Predator B mishap, but they are intensely interested in what we're doing, and so if we have something like adding data link communications that trips the recording requirement, they're really interested in seeing us do that. So there are a lot of aspects in this that intertwine, and I think the other thing is how much the comm group had to integrate with all of the other aspects of 228 and really all the rest of the agency. We spent a lot of time with flight standards. We spent a lot of time with Spectrum. We spent a lot of time with the real aircraft service, they say, not the headquarters guys. And so I would absolutely stress that. And one final, we're going immediately into phase 2, so that the working group 1 is, they've done a bigger job than we had, a massive job on detect and avoid. Now looking at ground-based detect and avoid as a complement to that. And we are moving to phase 2. We had a rousing discussion about how many international organizations think we're late already, which is great. That's just the way to start new work. But we have the next couple of years' work for putting this over SATCOM, looking at networking, and so there are a lot of to what extent the performance of our link is acceptable for what Working Group 1 is trying to do, and for what the rest of what a UAS has to do. So good. Well, I always learn more by listening, so I'm gonna turn it to Wes.
Thanks, Steve. Appreciate it. Well, again, I'll say thank you to the organizers of the workshop here today, and just say thanks for a few minutes here to just kind of give the group a little background on who I am and what I'm doing in the aircraft service related to unmanned aircraft systems, and then also kind of go through just some key areas that I think really need some attention and how we might be able to do that together. So I've been in the FAA for about almost 15 years now. I came to the FAA from a job that I had me out at NASA Dryden for a while, now NASA Armstrong, working on some of the X-planes and some advanced flight control systems and advanced technology. So when I came into the FAA, I went right into the Small Airplane Directorate's efforts to try to revitalize general aviation through the use of technology, to leverage technology to enhance safety. So I've been really lucky because I've been at the forefront of a lot of activities over the last 15 years, to bring new technology safely into our existing system, whether it's integrating glass displays into general aviation aircraft or taking a new regulatory approach with the light sport program that we did to use industry standards as a basis for certification instead of a heavy-handed approach by the FAA. And so we've seen a lot of really, great things come in the door in the Small Airplane Directorate, and we've taken some new and novel approaches to making those things work. And through that whole process, I have continually seen the benefit of what I would call judicious or appropriate application of human factors in the development of new technologies from the very beginning, or the integration of a technology into the operational aspects of an aircraft, or even after the fact in investigating, some safety issue with a technology. Human factors, I believe plays a key role in every aspect of what we do if it's applied appropriately. And so to that end, I guess what I'd like to talk about today is how we, in this symposium and this group, can talk about how human factors plays a role in the certification side, anyway, of human factors for UAS, which is where my particular interests lie. And, the three kind of key pieces of the puzzle that I see. One is how we apply a risk-based approach to certification. And Kathy had mentioned it, but our idea of this safety continuum, it's really just to say that we can't use the same approach for every type of product that we certify. And therefore, our certification approach and the requirements that we apply have to be scalable. And so this risk-based approach to certification has been put into action in the regulatory structure we're creating for unmanned aircraft systems, from the small, low-risk 107 rule that's just coming out to potentially some changes to Part 21 to allow us to handle some of the medium-sized UAS through a process where the industry is showing compliance to standards, but the FAA still takes kind of a light touch, and not a hands-off approach, but a light touch approach. And then for the larger aircraft, certainly using all of our existing procedures, all of our existing certification processes, getting involved early on to make sure that that human-machine interface is designed properly. And it was mentioned in the earlier panel, too, that we have a challenge of looking at existing designs and looking at new designs. And so there's really a lot to be mined out of that area of how we judiciously apply our known human factors requirements to existing designs, how we think outside the box to potentially accommodate new human-machine interface ideas and things like that. So the other piece besides the risk-based approach to CERT that I'd like to talk about a little bit is how we can start planning ahead. And that really ties into our research and development discussions and how we can kind of prepare for the future. And there's unique needs for the unmanned aircraft human-machine interface, for remote pilotage, for the displays, for things like that. But we need all that to be applied in a timely manner. So unfortunately, as was mentioned on the first panel, we're sort of in this idea of reverse dog years, where 1 year in UAS time is worth like 7 years in real world time. And underneath that challenge, we have to make sure we're putting requirements in place for evaluating the human factors for unmanned aircraft systems in place in a timely manner. And I hope we're learning lessons along the way from the industry, from the Air Force, from even from the consumer products industry, where they are designing human-machine interfaces that don't meet any of our existing requirements, but might be perfectly intuitive for a person to pick up and use. So, that's just kind of planning for the future. And then looking way down the road, how does our long-term automation strategy, from an unmanned aircraft systems perspective, how can some of those technologies, some of those human-machine interfaces be used to potentially revolutionize the way we all fly? And if you think about some of the concepts that NASA has with their on-demand mobility, they're really relying on flight controls, human-machine interface, automation, to all get to a point where we have like an Uber aircraft, where you can be a passenger on an aircraft and have it come pick you up and fly you somewhere and land. So obviously that's way off in the future. But if we don't think today about where we want to be in 10 years or 20 years, and we don't start putting the stepping stones in place to get us from our existing system to that future goal, we're not going to get there. And a great example I have is the Agate program that was done over almost 30 years ago now with NASA and the FAA to look at how to revolutionize general aviation. A lot of the concepts that are just commonplace now, the big moving map displays, the big wide format attitude indicator displays, the GPS technology, the advanced autopilot with envelope protection, all of those things were envisioned during the Agate program 30 years ago, and it took us that long to implement all this stuff. So, this last piece of the puzzle I'm thinking about are the advanced automation and future transportation goals. I think there's a lot of things that can be, brought to fruition there. So I'll just quickly kind of touch on each one. The risk-based decision-making process that we're using, you may be aware of the Part 23 rewrite that we did. It's in process right now. What we did for those regulations is we pulled the regulatory requirement up to the very top level safety goal. So I want the human factors community to be thinking about how to put our requirements for human factors into the context of the top level safety goal, rather than always focusing on does it meet the basic T or is red the right color to use in this particular instance. I want to be thinking about what the top level safety goal is and how we can put those type of top level requirements in place, because we are aware of the fact that sometimes our very prescriptive regulations can almost become a hindrance to advancements. Having said that, we also recognize if we completely destroy the boundaries that we're used to, we can have escapes from safety. We can have problems come into the system that we didn't envision. So we have to be very careful about how we kind of restructure things and how we take this risk-based approach to certification. We have a unique ability right now to use the small unmanned aircraft community as a prototyping community for some of these ideas. So, it really presents us the opportunity to put new technologies out there in a low risk, very structured, almost segregated, as was mentioned earlier, operational construct, gain operational familiarity with those, gain familiarity with the technology, and then allow those things to evolve to a higher level of criticality and use in our transportation system moving forward. So just making sure we're thinking about scalability, the right level of involvement at the right time during product development for human factors, and thinking about new solutions to a typical problem. Those are things that I would encourage. The kind of elaborating a little bit on the second point, which was, how can we prepare for the future and be looking ahead? Each stage of development of a product, whether it's a conceptual design on paper, it's the first time you're doing a flight test article, or you have an operational system that's going into wide usage in the NAS, there are human factors aspects that can be applied at each one of those steps. During the basic development of a product, you're looking at the basics of human-machine interface. What does the aircraft do when you lose link? Those kinds of things that Steve has mentioned. But then as you evolve the product, there are new things that need to be looked at. How do you integrate hundreds or tens of thousands of aircraft into an existing NAS in a safe manner? And sometimes these things are going to require us to think outside of the box. I think of our current cell phones. If you look at them, we don't have rotary dial technology on the face of our nice, screens on our phones, right? We went to the touch screens, or the touchpad. But I remember when the old phones, when I was a kid, went from rotary to the touch, the keypad. And it was such a huge revolution to not have to sit there and wait for the rotor, to go back each time. It seems like a very simple thing, but what if, by constraining ourselves to some of our current paradigms, we're inadvertently sticking to the rotary dial design instead of thinking of something that's outside of the box? So that's just one of my silly examples that I could use of thinking, looking towards the future. And then lastly, this sort of future concept for automation. I really have great interest in this particular area of what can happen for the future of aviation based on how we apply human factors now and plan for the future. I personally believe the technologies that we're prototyping in unmanned aircraft systems today will be the key for us solving all of our loss of control accidents for GA aircraft, a lot of our potentially loss of control accidents in larger aircraft, our traffic separation issues. A lot of those things could be handled through judicious use of automation, where the pilot is still part of the decision-making process and flying the aircraft maybe through the system and aware of the issues going on. So not completely autonomous, but allowing the pilot to be a better pilot because of the automation, or allowing air traffic controllers to be better controllers using the automation. One of the key areas that we're dealing with right now that is very real to me is for manned and unmanned aircraft systems. We have companies that are coming in with vertical takeoff and landing type of configurations where the aircraft is meant to vertically take off with electric propulsion multi-rotor type configurations, distributed lift, to be able to do a transition to fly horizontally at high speed, get you where do you want to go, and then land again. And everybody thinks that's something that's 10 years away. Well, we actually have 2 applicants who are at the Small Airplane Directorate today that are knocking on our door saying, we'd like to certify this in the next 5 years. So there's a lot of human factors activity that can be done during the unmanned aircraft, small subscale prototyping of those types of aircraft, and then the large-scale integration of those kinds of aircraft. And it was mentioned in the earlier panel as well, but it's a reality in this same construct is pilot skill level. For a highly automated aircraft like that, where you get in, you fly it, and it takes off vertically and transitions and flies you to where you want to go and then lands again, do we really need a private pilot to be able to fly that? Or do we need a system monitor that's got a big red button that says if something goes wrong, they push it and a ballistic parachute pops out and they land safely on the ground? So there's 2 extremes there. One is no pilot skill necessary except pushing a button. The other extreme is hand flying the aircraft through a very unstable, vertical transition type of mode. Which would we rather have the pilot doing? Do we want the automation to do it? Do we want the pilot to do it? So these are all things that could be looked at from a human factor standpoint. So I know some of that's kind of far out there, but that's kind of, I'm known for a little bit of that far out type of thinking. But I do appreciate the little bit of time to kind of introduce some of my concepts and look forward to questions we might get during the discussion. Thanks.
Excellent. So I thank you as well for me to this opportunity to speak to you all. I feel like a relative infant up here with the level of experience here in the FAA and certainly from a technical background. I've been with the FAA only 6 years, but I'm certainly not an infant, as you could tell by the gray here in my beard. But so again, Everett Rochon, I'm with Flight Standards and General Aviation and Commercial Division. Specifically, I'm with the AFS 820, which is the Commercial Operations Branch. I'm kind of dual-hatted right now. So one hat I wear as the branch manager, and AFS 820, just from a normal day-to-day operations. If you're not familiar, is from a manned operations perspective, covers everything from Part 91 piston aircraft to Part 125 sized aircraft, 757s, flown in various types of private operations. So, basically just about everything that fixed wing and rotorcraft that is not that does not fit under the air carrier umbrella. So that's kind of my day job, if you will, or was, but until I got plucked out of relative obscurity to for the Part 107 rule, and it literally happened like that. I mean, it was. I think there was some discussion here about the continuum of, how UAS, I think it transitioned from air and then to AFS 80, and then, from an OPR ship of and policy lead when it comes to UAS, it has it transitioned over to AFS 800. So that's kind of how I came into it, and it was literally, one day I was at work and there was activity going on with the rule and direction it needed to take, and my boss kind of tapped me on the shoulder and said, "Okay, you got it." And so next thing you know, I'm on telecons and everything else, and then I end up heading over to the Office of Rulemaking and to kind of figure out, okay, what's this 107 rule, where it is going. I've been familiar with UAS and the rulemaking activity, but a little bit more from a distance. We kind of were looking at it like, hey, AFS 80's got that, just let us know when it kind of starts to interfere with this manned operations thing we got going over here. We're kind of comfortable with our manned operations hat, so you guys kind of deal with that UAS stuff. But it did, transition. It was like, the head of Flight Standards said, hey, AFS 800, you have it from a policy perspective, and so, over there at the Office of Rulemaking, they said, you have it, you got to make this happen. And then, so I called up a buddy of mine, and I said, hey, we've got this tiger by the tail now. Let's take it And I had him come over. We sat in the Office of Rulemaking conference room, and we were there for literally the next 4 or 5 months and didn't leave. So that's kind of how we got involved in it. So I guess I'm partially credit, partially blame for whatever you don't like about the UAS rule at this point. But so right now I'm kind of working really rulemaking and implementation from a flight standards perspective. So forgive me if my perspective is a little bore-scoped on that, because that's really been my life the last year or so. Is everything having to do with the small UAS rule and how to turn it into a reality, for operations on August 29th when the rule becomes effective. So a lot of bits and pieces there, everything from the guidance material, pilot certification, training, you name it. It's really kind of a multifaceted effort, and the biggest challenge we have upcoming, not just when the rule becomes effective on 29 August, of making sure that we have pilots certificated who can conduct operations under the small rule, but it's this idea of the waiver provisions. So it's very, very dynamic. I think it's almost going to be an ongoing rulemaking effort in that regard. From a human factors perspective, me personally, I'm a pilot and an operator background coming from the military, from the Navy, and through the airlines. Then I worked flight simulator programs at the Pentagon for the Air Force. And I remember the day when UAS and those associated operations started showing up in the discussions at Air Force headquarters, and remembering what a tough nut it was to crack, how to integrate these operations into that manned world. And as manned pilots, it's really difficult to take that hat off and to look at this new paradigm. But so from an operator's perspective, from a pilot's perspective, I certainly have training and background when it comes to human factors and the effect on operations and safety. So I'm equally interested in it from a UAS perspective. How are we going to take, Wes was talking about his forward-looking and I don't know what term you use, pie in the sky or whatever you would. Could be. But how do you turn that into an operational reality? So all the things he was doing with his hands about lifting and transitioning and all this other stuff. So I guess we got to figure out how we're going to actually make that happen from a policy perspective in AFS 800. So looking forward to speaking to you all and absorbing what you have to offer to help us in that regard. Thank you.
Good morning, everybody. When Bill stopped by my office a couple weeks ago and explained to me what we're doing today, I kind of had a little bit of a pause on whether I should be the one sitting here or someone else from AFS 200, but it didn't take much convincing. Basically, I'm here for selfish reasons, first of all. I want to learn more about what we're doing as a group, because it seemed like the last year or so I've been involved in this type of, in this project. I see a lot of people working hard. It's just maybe we need to, collaborate a little bit closely with each other. A little bit about my background, kind of like Everett mentioned, I'm a pilot. I've been a pilot since 1985. I don't consider myself an old-timer, but years add up. That's 31 years, right? So I've been a pilot all my life, my professional life, a little bit in the military, a little bit in civilian, and then I joined the FAA in 1997. So that's also a big chunk of years. But all my assignments, all my work activities had nothing to do with UAS, primarily flying airplanes, inspecting operators, certifying pilots and airplanes and that kind of stuff. I had a period of time when I did international work in flight standards. We used to assess civil aviation authorities. So I had the pleasure of visiting a lot of countries and dealing with their traditional system safety oversight. Nothing related to UAS, other than some of them didn't have any qualified personnel, so we called them unmanned operations. And then last July, I came back to flight standards from an assignment in Russia. I was the FAA senior rep in Moscow. A lot of excellent exposure to a million other topics, such as national security, geopolitical issues, airspace, cross-polar, but had nothing to do with UAS. So my involvement in UAS has been since I came back to Flight Standards AFS 200, the Air Transportation Division. And my branch is the new programs branch. So basically, this fit under the new programs. So, and I'm lucky in my branch and in the division that we have the right people for this project, for this conversation. We have human factors experts. We have unmanned aircraft experts that actually worked in AFS 80 before the transition. So we have the right people. However, I don't, a big disclaimer that we're learning about the technical aspect of UAS aircraft, the aircraft part of it, and the air traffic part of it. And what I have to say is that everything that we will do in the future as AFS 200 in the air transportation business will be based on the work that's being done by, we'll go in this direction by 800, because they're the focal division for flight standards when it comes to the foundation of pilot aircraft operations, qualifications required to operate a UAS. And, air traffic folks, aircraft certification folks, I was talking to Wes about some of their projects that they're working on. It's just, the technology is moving so fast, it's not really feasible for us to set a certain set of requirements, and then before you know it, the technology is way beyond what you imagined. So someone mentioned that this is like the invention is the mother of necessity. So you invent it, and then we'll find a use for it instead of the other way around. So we don't know what we don't know. However, our shop we've worked hard with, human factors, research and development, with all the LOBs, 800, AFS 800, AFS 400, the UAS office, even NASA and, the outside the industry folks, on staying connected with this conversation. We cannot just go away and say, when you're done, let us know. We'll start talking air transportation. We are engaged. I have people that have nothing to do but telecons every day, all day long, from 9 to 10, 10 to 11, and all. So basically, we have certain concepts that we believe they're going to work regardless. Air transportation, like in manned operation, it's a step beyond just operations under Part 91, let's say, of a manned aircraft. So when 800 decides, okay, for a pilot or for an operator of a UAS size, qualifications, capabilities, you need X, Y, Z, then to fly or to operate that UAS in air transportation for air carrier type, for compensation or hire to take a package or cargo or even a passenger in the future from point A to point B, that takes it to the next level of the highest level of safety that we're obligated to maintain. So on top of the requirements, the basic requirements that we will get, we will take a look at the rules. Current rules are 119, 135, and Part 121 that enables air carrier type operations. We will either update those rules to include UAS type requirements, or we'll just develop a new set of regulation that applies to UAS. So that's in general what our frame of mind. We have few operators that are already applying for a Part 135 type operation. Some of them applied. We went through the motion. We just talked with them a little bit. We had group discussions, and then they decided with the brand new 107 rule, they don't need a 135 type or 135 like authorization or certificate. A couple of them are still in the system pursuing a 135 certificate using UAS. So what we're doing, just so you know, I mean, for the sake of this conversation, we're more on the process right now rather than the technical aspect of UAS. We're just following what we have currently, is that the applicant typically will contact the field office, will apply for a 135 type certificate. The difference here is that right away the field office will involve headquarters. That's a difference from a normal process. And then we will have more of a group certification project rather than just one inspector or one team in the field. And the idea is, and this has been proven, I guess 800 a few years back did a Part 137 project in the same manner. An agriculture operator applied using UAS, and they followed the guidance that we have. But what we're doing, like they did, we will update the guidance. We'll request deviation from whatever existing guidance that we have that doesn't apply. We have a process for that. And also, the applicant will have to learn about what they're proposing and what's existing in terms of regulations, and they would have to decide that which regulation they can comply with, which one they can't, which one does not apply, and then we'll go through the exemptions process. So they will have to give us a list or identify the rules that will not be applicable or cannot be complied with. So with the regulations, the guidance, our inspectors also will be helping us draft new guidance, new ACs, advisory circulars for the public. So hopefully, if we get to complete one project, we haven't yet, we kind of just starting right now, by the end of a project under 135, we will have an idea, first of all, can it be done under the existing set of rules? Or is it more practical to forget 135 and have a 136.5 or something like that, or 108.6, whatever, something new that applies to UAS, because most of the regs right now deal with manned requirements, you know, oxygen. When you're flying above 10,000 feet, you must wear oxygen. Well, this is not gonna, unless there's a possibility if we have an optionally piloted aircraft where it's a combination between remote and manned. So that's the process. We already identified a few miscellaneous things that we know we need some research requirements on, such as when you get into the air carrier business, we have flight crew and duty rest requirements, fatigue requirements beyond what the manned research has done already. An operator sitting in a control position on the ground, is there any fatigue related to that? Similar to maybe an air traffic controller or something like that, although it's not the same. Training, how much stick and rudder skills do you need? It depends on the type of aircraft. Again, I'm not sure what we're going to end up with from the aircraft certification side that operators will use in air transportation, but it depends on the platform that they're proposing. We may have a combination of knowledge and skills, or even just knowledge. And I'm talking above the 55-pound level. When we get into a expanded type operations in the NAS, non-segregated, you may have all the way up to fully autonomous and automatic type operation where it does not need any skills. Fully auto land, auto takeoff, push a button and it'll fly from point A to point B. But it will require responsiveness, like the folks from NextGen mentioned, that if you have a contingency, you don't need to fly the aircraft, but you need to respond to air traffic instructions. So some of those are identified, and we have a list of bullets that we're working with the AUS office on. However, what we're going to do in the future, or in the near future, before next week, I guess, we're going to have to think about bundling them together, maybe to have at least 2 or 3 bullets, and we will focus on those requirements for the next couple years, FY 18-19. In the meantime, we're watching what's happening on this side, and then hopefully in dog years, 3 years, I'll be gone. No, I'm just joking. We'll have a better idea. So thank you for having me here. Thank you, Bill. And looking forward to your questions or suggestions. Thanks.
Yeah, I'd say right now, first of all, thank you, everybody. That's a good overview to get things started. Looking at the clock, it is about 10 minutes to noon. So I suggest that we go ahead and start the Q&A with the Human Factors panel. And then what we'll do is continue this in our last session, because all of you will be involved in the last session of the day. The difference will be these guys won't be around to necessarily hear it. Maybe some of you will. But we can at least get the questions to them and address them if you're not involved in the other ones. And I guess we should also be mindful because Wes has to leave after this, I think. Yeah. And Kathy wants to say something.
Yeah, I just wanted to remind everybody, although the focus of this discussion seems to be on human factors research, there's more to human factors than research. There's application of the knowledge that comes out of the research and the basic knowledge and science and engineering that we have from human factors. And I just wanted to make sure that we keep that in mind, because the kind of human factors support, and we'll talk about this later, is not just research support, although that's critical. It's also the human factors practice and implementation, to be a part of that implementation in our policy, our guidance, and so on. That's part of the reason we have people in AVS who are not just researchers or who are not researchers at all in human factors. So we need both, and so I would ask that some of the discussion take that into account.
Phil, do you want to start? Go ahead.
I think both Everett and Kathy were mentioning this safety continuum. And to me, one of the big issues that we have to be worried about is sort of the trade-off between safety and efficiency, in the sense that if we look at, say, the Metroplex, RNAV sorts of programs, what we in many cases have seen a program that had efficiency goals struggled to achieve them because the operators went beyond what the procedures said in terms of building in safety buffers. And I think that's a much less what we're trying to deal with now is much more challenging than that, in terms of saying, whether it's in terms of technology, whether it's in terms of procedures, whether it's in terms of roles and responsibilities, what people will really do may not match what the procedures say in terms of these safety buffers. And so I'm less looking at the issue of not equal safety for, say, small, in some sense I think you're implying, for some small operations versus large operations, but rather that there's going to be this trade-off where if we don't think about the human factors from a systems perspective, how does the pilot's behavior influence what the controller, what we should do in terms of airspace design so the controller's behavior is efficient? And that sort of systems view becomes a critical issue that human factors is part of. And then just any thoughts you have on how do we approach that so that we don't design for sort of the stovepipe part of it. Here's something that looks good in terms of ground control workstation design, but in terms of the behaviors it produces, ultimately leads to a failure of the efficiency goals, or in some cases, failure of a safety goal.
Go ahead.
Well, I'll just kind of talk, and I appreciate the comments about the, not just about the safety continuum, but also human factors from an application standpoint. And I'm not sure we do that very well. I think we, and I'm interested to hear how Ely interprets it in AFS 200, but at least with what I've seen in our division, the work that you all do, trying to take that and actually turn it into implementation and turn it into policy every day. And maybe that's a result of several things. We always have certain projects and things that get pushed up ahead of the things that we see as critical. But I think there's this disconnect between the research world and the work that you're doing, and now how do we capture that within our line of business and then turn that into real world application and policy or incorporated into regulations. There was mention about performance-based standards and things like that. We're, at least in 800, we're at very infant stage when it comes to developing these type of performance-based standards and integrating these type of things. We're, now trying to transition from prescriptive to risk-based to performance-based things. So I think we need to do a way better job of doing that. I don't know if it probably doesn't directly answer your question, but at least to me, it goes to the things that we need to consider and the things that we need to improve on. And now we have this new, we don't even do that well in the man world, right? We try very hard. But I think now that we've got the UAS world, how do we now assure that we do that? And we almost have to, because the technology and the operations and the things that we even are sitting in our chairs now, it's going to way change in the next few years, right? So we've got to come up with a way of interacting in a way that allows this to grow and to develop, so that from a safety perspective, we capture these things, and now from unmanned pilots and manned pilots not just operate safely in their own sphere, but now can grow in that those operations can integrate safely.
Yeah, I totally agree, and just we're so lucky that this is such a new thing that we're working on, that industry and research folks and the regulator, they're all in the same boat. They're all working on the same project to achieve a result. And also, the FAA, at least from what I've seen, has done a good job the last year or two refocusing this conversation strategically, and we have an implementation plan now that is going to be finalized hopefully pretty soon. And everybody is involved in that conversation within the FAA and even outside. And so from an efficiency standpoint, we're open to, new concepts. So, unlike, the guidance and regulations that are 30, 40 years old, we're still applying them today. Some of them changed, but a lot of them have not. Now we're talking brand new set of rules, brand new set of guidance, concepts of certification and oversight and performance-based type, risk-based type aviation safety. So I think that's a luxury that we have right now. So we're on my side, 200, the Air Transportation Division, like 800, we're open and we're open-minded.
Wes? Sorry. Or Valerie?
So I have a question that kind of follows on a little bit, maybe to what the tone of this is. There's a lot of innovation in industry, a lot of people are bringing new ideas, looking at new ways of doing things, and I think that creates some challenges into what expectations should be as we design components of the overall system. So I came here and I need to leave to go back to RTCA, where we're working on standards for a collision avoidance capability for UAS. They'll be finished by 2020, and as part of that, we have some human factors types of requirements that we need to implement. But in the manned world, there's Part 25, Part 23 standards on what a cockpit looks like, what an operator looks like. And having been in many ground stations and seeing a variety of displays that are reconfigurable, that the operators can move, get rid of, when should we expect, or should we expect, guidance from the Aircraft Certification Directorate, from AR130, from Flight Standards, on what we should expect as a baseline capability or baseline expectation as we develop these systems? Or will we expect that at all? I mean, this has implications when we have a MOPS that's due in 2020. Clearly, we're late for research. We rely, like Kathy said, on experience. But we need to have some common understanding, or even what level of risk we should be mitigating in the system design. And should we partition that to the pilots or the operators or to the system? And do we have expectations on a ground control station standard or a pilot standard for, let's scope this into the mid to larger size UAS?
So I'll just quickly address at least part of your question. We in Aircraft Cert, recognized back when Steve was talking about when some of the UAS work was going on under Air 160, before it went over to the flight standard side of the house, that there was a need to put together standards for the ground control stations and for, those core pieces of the unmanned systems. And there was an effort under the 203, SC203 group, a little subgroup that was started up to look specifically at the ground station and the control station characteristics. And so we have some guidance, some white papers, some information that came out of those studies. Some of that was published, at least internally, in a draft AC that we've created that is still kind of going around for some revisions. There's the struggle of how much do we put out there to be prescriptive as a best practice document, and how much do we allow to be sort of open to new ideas. As you mentioned, there's a sort of a continuum there of, do we let everything be completely new, or do we make people aware of the existing guidance and say, follow what we know? And so at the current time is if the ground control station looks like a typical cockpit or flight deck, then we say follow some of the guidance and make sure you're aware of, the existing human factors and the existing cockpit design, display design guidance. If it's something that's a handheld controller that completely is something different, then a lot of times those design characteristics don't really fit. It's a square peg for a round hole kind of thing. So those we have to be aware of, basic color usage. We have to do multi-pilot evaluations potentially of looking at those systems. Through our certification work so far, we've run into this very issue where we had a handheld controller that had years of successful service and very demonstrable, safety record that it was working well. And yet there were a lot of things about that when we started evaluating it for our airworthiness and certification of it that didn't fit the bill. And so we had to kind of go back and say, okay, we have to back up one step and say, is what's there, does it meet the intent of the safety goal, which is an intuitive human-machine interface, sort of like some of the new language in the 1302 rule says, make sure your automation is intuitive and easy to use. Well, that's kind of the mindset we've taken with some of those evaluations of some of the handheld controllers that are outside the box. But, on the other spectrum is if it looks like a standard flight deck, if a pilot, a certified pilot's going to be flying the system, then we want them to adhere to best practice as much as practical.
So Wes, I have a follow-up question on this topic. So we're going to be going into FRAC for the final detect and avoid MOPS. And we have assumptions about the ground control station capabilities because we were not writing MOPS for the ground control station. We were writing MOPS for the detect and avoid display.
Right.
So how do you, as the FAA and the co-chairs involved with 228 and the policy that will come out as a result of the MOPS, make sure that they're aligned so that we don't have gaps? If we're making assumptions about what the control station can do, how are you ensuring that that's what the control station can do and that those MOPS are applicable to those ground control stations?
It's a great question. So specifically for the MOPS and their applicability according to the terms of reference, those aircraft are most likely going to be certified using what I would consider to be more traditional design characteristics for the control station because they're large, high-altitude aircraft. They're, remotely piloted where somebody's in the loop making sure that they are monitoring. And, so from my perspective, I believe that the MOPS will fit well with, the existing guidance and the assumptions that you've used for those terms of reference. The challenge, of course, will be as the next phase comes online and we start looking at other types of UAS operations, maybe lower altitude, smaller aircraft, those kinds of things. That challenge, we'll have to make sure those assumptions still hold true. So, Steve, I don't know if you have any comments on that.
I think that's exactly right. One of the challenges I already mentioned with 228 is we did not start with a mast. We don't have a aviation system view. We were going to just build me these two pieces of equipment, so that we do have the both the TSO and the advisory circular concerning both DAA and command and control are on the business plan for next year for 17. So those will be out. And I think the other thing that's key is I make sure to attend Wes's coordination meetings to make sure that I keep the 22H call out in Wes's overarching AC. So Wes has an overarching AC for all of UAS, and that ties in and recognizes the 228 work, but certainly there's work above that. And in phase 2, we speak more to that in that we have a little bit of a mass flavor to decide what we're doing for SATCOM, but people in general are very leery, build me a scale model of the NAS. Well, bring me a piece of paper the size of the NAS and I'll get started. The fidelity of the model is always hard for us.
So my question is relatively about the risk-based certification issue. And perhaps this wasn't the way you wanted to go with it, but to me, it seems like we're focusing so far on size as a driver of what the certification standards should be, particularly, well, for instance, for the controllers, for the control system, that is. When it's small, you use a handheld. When it's big, you use a control station. I'm not sure that that's necessarily the way we should do it. I'm wondering how much, if anyone has thought about looking at the application of the systems as at least part of the driver for the certification requirements in the control station, and maybe some other factors too. But
Yeah, so I can start to address that, and then I'll pass it on. But in the draft AC that we created, we recognized right off the bat that weight, is not the best weight, size, speed. All these parameters it's a very difficult thing to sort of classify UAS and try to put a risk category associated with those. And we made an attempt of that using energy because we figured, well, okay, if it's large and fast and can do a lot of damage to things on the ground or to other aircraft, we want to apply a high level of certification to it. If it's small, low energy and is going to bounce off of something if it hits it, then we don't really have a high level of risk or worry from the FAA standpoint of integrating those into the NAS. But to address your question directly, we absolutely believe that you have to take into account the concept of operation, type of aircraft, its intended mission, and where it's going to fly, the type of airspace, to have a complete understanding of what the design requirements should be. And it's been a great learning experience for me because I was looking at things 2 years ago when we wrote the draft AC from a very aircraft certification centric mindset, which was speed, altitude, weight, that kind of thing. And I've gotten my education of airspace integration and thinking of this problem from the term of how they integrate into the NAS. And so I'm starting to think more on the lines of the first panel this morning, where we have either segregated or integrated operations. And that's playing a part of the puzzle now. So one of my first decision points in the revision that we're going to do to the AC will be, is it a segregated operation or is it an integrated operation? And if so, that has really two separate decision trees to go down. And then underneath that, we would have this similar sort of classification scheme that we've been using, where if it's a high-risk operation or high-risk large aircraft, we'll apply a heavier hand. If it's a low-risk light aircraft that's not going to hurt anyone, we'll take a light touch to it. I don't know if anyone else has any other thoughts on that.
Just quickly, from a flight standards perspective, 3 words come to mind, and that's crawl, walk, and run. So right now we're very much in the crawl stage, and so when it and I'll just keep using 107 as the basis, but we had the proposed rule, which was basically the way we started. So we really couldn't go beyond that at that stage, and even operations over people and these type of expanded operations where there was a lot of willingness, especially from industry, to push that as far as you could go, to get more performance-based in that rule, to expand the operations beyond what in the crawl stage. but we really, because of the time and the pressure and other things to try to get that rule out to enable the operations, we kind of had to stay in that box. And so, you know, a lot of the hard decisions, we kind of kicked down the road to the next rulemaking effort. So from a Part 107 perspective, you know, the operations over people, the anything beyond visual line of sight was all kind of pushed next. So, you know, within our rule, the weight and these very prescriptive speed and altitude things, and just making sure that you stayed segregated from the manned community, except in specific instances, was the key, and really just kind of had to stay in that box for time and for reasons of just plain experience. We have to do this level now and then see what we've got, because we really have no idea what we're going to have after August 29th. And then we'll be able to use that experience to move forward into some of the more advanced thinking.
So as you move forward, I think it'd be good to have a process for how we can engage to address your needs. And so maybe it's something for everybody to think about. But you know, there's a lot of ideas about, you know, and you guys mentioning that, yes, we need this and that. I don't see you know, we have our usual research processes and other processes, but for general application support in general for human factors, it's not clear to me how we kind of engage in your world. So maybe you can have some ideas about it. We don't have time to talk about it now, but we're running over now, so we should probably cut this. But everything you guys heard today, let's follow up in the last session. You know, we're going to have all of you involved, except for Wes, he has to go, in the last session too today. So keep that in mind, and I'll just put an action item for you guys to think about how we can get engaged in your needs. Anything else, Kathy, or any quick
No, I think
closing
that's,
remarks?
No, I think that's fine, but let's do have the follow-on discussions, especially this afternoon in the last session.
Okay, so this concludes panel 2. Thank you very much to all the panelists here. And to all of you in the front row who will be joining us again later in the day.